This is a robotic actuator. It's one of the key components in advanced robotics like humanoids or quadrupeds, allowing them to move like this. And this is my SA7037. It can do most of what professional actuators can, but costs over 5 times less. But let's start from the beginning. Every robotic joint needs a motor that can move it. A motor with high torque that constantly knows its position and can adjust it very precisely. This means it cannot be just a motor, but a component that includes a motor, a reduction, and something to measure the angle. The most basic component that has all of this is a DC servo motor. Those are the most popular ones, mostly because of the price and ease of use. They work well until you need to do more than just move from angle A to angle B. Even something as simple as acceleration or speed different from the default is a big problem. I mean, it's kinda possible if you try hard enough, but they aren't designed for this, so it's not going to work well. That's why professional robots use BLDC based actuators. They are light, energy efficient, and very precise. They can achieve any motion and dynamics you need. However, the cheapest one with a torque of around 3 Nm I found on a Chinese website cost over 130 euros, and I'm not even sure if that includes the FOC driver. Okay, I think it does, but still, it's more than the entire budget of many small projects. Plus, they are hard to use. That's why when I was building my robotic arm, I looked at a third option, stepper motors. Those are also widely used in professional robotics, but are much cheaper. It's a perfect compromise, giving you almost all the movement options at a great price and ease of use. But here's another problem. Even though they are a great solution, there is no ready-to-use actuator made with them. Only those reduction grid boxes, which cost more than the motor itself, that you need to integrate with something that measures the angle or home the motor by yourself. That's why I made my own, the SA7037. It's a 3D printed NEMA 17 based actuator with a closed loop feedback, 9 to 1 belt reduction, almost 4 Nm of holding torque, less than 1 degree backlash, and most of the motion dynamics that BLDC actuators have, but cost only around 25 euros to make, depending on where you buy the parts. Of course, there are a few things that BLDC actuators are much better at, like energy efficiency, weight, precision, and the ability to adjust the strength or feel, which is very important for projects like humanoids, but for most home projects you simply don't need that. And the stepper actuator like this is just enough. I leave a link to download all the files and instructions from the course in the description. Soon I'll expand the series with much stronger version of this actuator. Plus I want to start making much crazier projects on this channel, so subscribe if you don't want to miss anything. But for now I think that's it. Thanks for watching and goodbye.